Okay, today we're going to start lesson 7.1 on polynomial functions. I have an example of a polynomial function up here to start the notes. The first thing we're going to look at are our zeros, which are happening here, here, and here. So the 0 here at -3 is passing straight through. That means it occurs one time in our equation. The 0 of -1 here shows a bounce happening. That means it's going to occur twice. And the 0 here, it looks like it's about 2.5, but it's passing through as a cubic function. That means that it's going to be happening 3 times, occurring 3 times. We're also interested in end behaviors. So as x is approaching positive infinity, f of x in this case is approaching negative infinity. It's heading down. As x is approaching negative infinity, f of x here is also approaching negative infinity. That helps us to figure out if our leading term will be an even or odd exponent. If the zeros are heading in the same direction, it will be even. If they're heading in opposite directions, it will be odd. Okay, so the first thing I'm going to do is be able to look at a graph and write the equation. So the first thing I want to look at here is I see our end behaviors up here are both heading towards positive infinity. So I should have an even exponent or degree of the polynomial. I see that I have a 0 here at -2, another one here at 1, and another 0 at 2. So our equation is going to be f of x is going to equal some constant value. That's something we're going to need to solve for. And we're going to base it all off the zeros. So x is at -2, which means that it came from x plus 2. And again, it's passing through like a cubic, so that is occurring 3 times. We have another 0 at 1. It's passing straight through, meaning that it's occurring twice. And we have another at positive 2, so that came from x minus 2 with a bounce, which means that's occurring 2 times. In order to solve for this a value here, we need to plug in another point. The best point to plug in would be the y-intercept, so long as it's not also a 0 of the function, which in this case it is not. So we're going to plug in the point 0, -4. -4 will replace the f of x because that's our y value. We're solving for a, and we will put zeros in for all the x values, and then we'll go ahead and multiply that out. We wind up with -4 is equal to -32a, and a winds up being 1/8. Once we have that constant, we can go ahead and write out the full equation. So that would be our final answer for this guy here. Looking at B, again, I'm looking at something that's starting in positive infinity, ending in negative. That means the polynomial degree will be odd. I also should have a negative a value that will come through because they're starting in positive infinity, ending in negative, so we kind of have a downward direction happening here. Again, we're going to start off with, let's get it on the board here, f of x is equal to some constant value. You don't need to put the negative in. It will be driven out by the numbers themselves. I have a 0 occurring at 0, so that's going to be represented by x. We have 1 at -4, so that would look like x plus 4 with a bounce. So that means that multiplicity is 2. We have another 0 happening at positive 2, so it's going to look like x minus 2, and 1 at 5, x minus 5. I cannot use the y-intercept in this case because it's also 0 the function, so it's just going to come down to 0. We need to find another clearly defined point. We've added 1 in, so you can know for sure exactly what that number is. We'll put 10 in for the f of x. We're looking to solve for a, and -2 will be replaced in for all the other x's. Calculating this out, we get a to be -5 over 112. And then we can write our final equation, negative 5 over 112 times x plus 4 squared, x minus 2 times x minus 5. There is no need to multiply all that out. It would be just too big of a calculation. Okay, flip your papers over. We need to be able to look at an equation and be able to give us a basic sketch. The three things that we're going to be looking for are end behaviors, how the zeros are passing through the x-axis or bouncing, and also the y-intercept. So I look at the equation here. I can see I have one x-intercept at 0, has an exponent of 2, so that means its multiplicity is 2. We have another 0 at 3 with an exponent of 1, so its multiplicity is 1. And another at negative 4, again with a 1 exponent. I add up the multiplicities here. That's going to give me the degree of the polynomial, which is 4, which is even. That means both end behaviors are happening in the same direction. Since we have a positive lead on the polynomial function itself, both end behaviors will be happening towards positive infinity. Since we have an x-intercept at 0, it means our y-intercept will be at 0 as well. All right, so let's put the zeros on here. We have one at 0, one at 3, one at negative 4. I know both end behaviors should be occurring heading up. So as we get to the negative 4, it occurs twice. That means we're going to pass right through. We're going to make a turn heading towards 0. It's occurring twice, which means a bounce will occur. And 3 was happening once and heading up towards positive infinity. At this point, we're not concerned about exact values, exactly where these graphs are turning. These are just basic sketches. If you were to find them, you would just plug negative 2 in for the x's and 2 in, you would get some values. But again, we're just looking at zeros, end behaviors, and y-intercepts. We will ask you what intervals are above the x-axis. So that's anything occurring up above here. So, and when we give intervals, we're always given the x, the domain values. So starting at negative infinity, we're coming in. It stays above until we get to negative 4. It has a soft bracket because at negative 4, it is on the x-axis, not above. And then it picks back up over here at 3 and continues on to positive infinity, staying above. Intervals below, we're picking up at negative 4 and getting to 0. We cannot include 0, so we'll pick up on the other side until we get to 3. Okay, let's look at example number 3. So for example number 3, we have g of x here. We're going to start with the zeros. I can see that I have a 0 at 2 with a multiplicity of 3. I have another one at negative 4 with a multiplicity of 2. And then we have this guy looking a little strange. If I were to solve this, I would get x squared is equal to negative 5. We cannot take the square root of a negative number. For x-intercepts, you can just write that they're imaginary. And then it has a multiplicity of 2. The multiplicity will still count for the degree of our polynomial. However, since it is imaginary, it does not show on our graph. We don't know exactly where they're sitting. So this guy has a multiplicity of 7, which means the degree of the polynomial is odd. I can see that it is positive lead, which means we should be heading going upwards. So it's going to start in negative infinity and end in positive infinity over there. I do not know what the y-intercept is because I haven't solved for it yet, and we don't have 0 listed here. If you put 0 in for all these x's and made the calculation, you would find that the y-intercept is a really big number. It turned out to be negative 640. Okay, we can fill out this part here. As x is approaching positive infinity, f of x is also going to be approaching positive infinity. And as f of x is approaching, as x is approaching negative infinity, f of x is approaching negative. Let's get our zeros on there. We have one at -4. We have another at 2. And we also have this crazy y-intercept. I'm good if you just put a point in there, label it -640. I know it's not realistic, but it's enough to let us know that you know exactly what it is. So as we're approaching -4, the multiplicity is happening twice, which means a bounce should occur. So coming up to -4, we're going to make a turn. We're going to go to the y-intercept and through there, and then it's going to turn and come up, kind of looking like a cubic function there, because that multiplicity is happening 3. Intervals above the x-axis is only in one spot here. It's above over here, so that's starting at 2 and heading towards above. Yeah, so just at 2, heading towards positive infinity. Intervals below the x-axis would be happening at, let's see, -infinity till we get to -4. Unions with, on the other side of -4, soft brackets again until we get to 2. All right, we have one more example for you. I am looking at g of x here. Let's start with the zeros like we did last time. So I have one occurring at 0, that's happening twice, there'll be a bounce. Now this is a little different than the last example, because if I was to solve this for 0, I would get x to be plus or minus 3. Those are real numbers, so I'm going to have positive and -3. Each one has a multiplicity happening one time. And the last one is 6, and that one is occurring twice. Since our x-intercept is 0, that means our y-intercept will be 0 as well. If I add all these guys up, we have a polynomial of degree 6, which means both end behaviors are happening in the same direction. Since the actual polynomial is negative, both end behaviors will be happening at -infinity. Alright, so let's put our zeros on there. We have one at -3, one at 0, one at +3, and another one at 6. Okay, so as we're approaching -3, it's going to just kind of pass right through there straight. And then it comes to 0, we're going to get a bounce off of there. And then as it is passing through 3, we're going to turn, go through 3, and then we head towards 6, there's a bounce there, and it heads back down towards -infinity. Not the prettiest graph, but it does represent everything that we need. Intervals above the x-axis are starting at -3, soft bracket, heading towards 0, picking up on the other side of 0, and ending at 3. Intervals below, we're starting at -infinity, heading to -3. Then we don't pick up again below until we get to 3, and heading towards positive infinity on that side. That's it for today's lesson, and we will pick back up with 7.2.